Hi guys, very warm welcome to the Logistic Regression with Python using Scikit-learn lecture. In the previous theory lecture on logistic regression, we have learned the key concepts and working principle behind the logistic regression model. It is time to learn by doing. We are going to explore another very famous dataset on Titanic disaster. The dataset is also available on Kaggle for you to download. This dataset is considered the first step towards classification in machine learning. A detailed description is provided on the dataset at Kaggle. However, the data dictionary is given in this notebook as well. So you have the following columns in your dataset: passenger ID, survived, 0 for no and 1 for yes. P class is the ticket class, first, second, and third. Name of the passenger, sex male or female, age in years. Sib SP, number of siblings or spouse. Par CH, number of parents or children. Ticket number, fare, cabin, which is cabin number, and the port of embarkation, C, Q, or S. In this classification problem, the goal is to predict if passengers survived the sinking of the Titanic or not. First, we will do some exploratory data analysis and then use our understanding in logistic regression to train the model for classification. We then deploy our model on test dataset and see how well the model does predictions. You can directly download the test.csv and train.csv from Kaggle. However, the files are included in the course material for your convenience. Let's jump onto the new notebook and start working on our project. So the first thing first, let's import some libraries. At this stage, I'm sure these libraries are not new to you. So import pandas as pd, import numpy as np, and import matplotlib.pyplot as plt, and another one import cbon as sns, and then set matplotlib inline, and let's run this cell. A CSV file train underscore Titanic is given. Let's load that file into train. Train equal to pd dot read cs3, and if you press tab, this is the file you need here. So let's run this cell here, and as always, let's check the head of the data. So train.head, and here we have column on passenger ID, survived, P class, name, sex, age, sib sp, siblings or spouse, parent, children, ticket, fare, cabin, and embarked. Let's add few cells here and move on to the exploratory data analysis. Let's call info on our train just to have a quick overview on our dataset. So train.info, and here we have. So we have 891 entries in our train dataset with column names on the traveler information along with other information such as passenger class, fare, ticket, cabin, and so on. Notice that each column has 714 non-null values, whereas cabin have 204 non-null values. Embarked also have 889 null values, so there is some missing data. So we need to deal with the missing data as well. Let's do some calculations to find out the percentage of missing data in each column. Remember, we have function isNull in this situation. So let's call isNull on train. So train dot isNull, and if we run this cell, and here we have false, 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 and true. So if the value is NaN or missing value, it's returning true. So this is a data frame with false and trues. If we call .sum, we see that we are getting passenger ID 0, survived 0, and age 177. So we have 177 null values in age. And cabin, we have 687 null values, whereas embarked, we have 2 null values. So to calculate the percentage of missing values, we have to divide number of null values or number of missing values to the total values. So let's call count now, train dot count. And if we run this cell, so the count is returning number of non-null observations in each column. But we want total number of observations in each column. Either we can grab a single column here, and to do so, you need to make sure that the column has no missing value, or you can call isNull here as well, like this, train dot isNull dot count. And if you run this cell, so you're getting all observations null or non-null in this case. So to calculate the percentage of missing data, let's grab this one here and put the parentheses around train underscore null dot sum, and then divide this by total number of observations in each column, and then multiply this by 100. And if you run this cell, so there's no missing data in passenger ID, survived, P class, name, and sex. Age has 19.86% missing data. Cabin is the biggest number here, 77.10% missing data. We can use round function here. Round, and we want, let's say, only 1 here. And if we run this cell, so here we have a rounded data now. Age is 19.9% missing, and cabin is 77.1% missing. Let's pass into a variable so that if we want to use that at later stage, so PCT percentage missing data, and run this cell again. And if we run this percentage missing data, we have these values in this variable now. Let's recall and refresh our skills in dealing with missing data. IsNull returned true for all the places where the data is missing. Our dataset is large. We better think about graphical visualization using Seaborn's heat map method. Let's try heat map and see if we can get some visualization of missing data in the heat map. So SNS dot heat map and pass in data equal to train dot isNull. And let's run this cell. So here we have a heat map. This might be okay and tell us that there are lots of missing values here in cabin and age, and few in embarked as well, but we can improve this heat map. Why tick labels are overlapping here, and we may not need the C bar as well. We can also use C map to different color scheme for better visualization. Let's copy this function here, paste it here, and then we don't want these labels along Y, and we don't want this bar. So Y tick labels, set them false, and C bar false, and let's set C map equal to Viridus, VIR IDIS. And let's run this cell again. And here we have much better heat map. We can clearly see that lots of carbon data is missing. Age column has some missing values, and embarked has a couple of missing values as well. Well, we want to know more about the dataset. We can use count plot to see how many survived and how many died. Let's call count plot and pass in x equal to survived. This is our column which has 1 for survived and 0 for not survived. And our data is train. And if you go back and check, this is the column here, survived. It is with capital S. Let's copy this one and paste it here. And if we run this cell, here we have a count plot. It is sad that not many passengers survived because count is higher for 0. We can explore further on this data. What if we pass in hue argument here? Let's copy this one and paste the code and pass in hue now. And let's pass in sex and rerun this cell. Now we have further information from our plot. Male is in blue and female is in green. So this plot suggests that not many males survived in the incident, whereas most of the females survived. We can ask another question here. We know there were 3 passenger classes in the Titanic. Which class survived the most? Let's call unique on P class just to recheck the number of classes in the dataset. So train, grab P class column and call unique. And if we run this cell, we have 3 classes, 3, 1, and 2. So let's copy this code for count plot, paste here and pass in P class as hue, just to see which class survived the most, and run this cell. Here we have P class 1 is in blue, 2 is in green, and 3 is in reddish color. So now we got even better understanding on our data. We know that more than half of the class 1 passengers survived, whereas most of the class 3 passengers died. Let's add few cells and explore little more on our data. Let's see what was the survival rate based on the port of the embarkation. We can call count plot on embarked column here and pass in hue as it survived to see the survival rate based on the embarkation port. So SNS dot count plot X is survived and our data is train, and then hue is survived. So we want to check embarkation port, so this should be embarked. And let's run this cell, and here we have S, C, and Q. There are 3 ports in the dataset. Blue is for died and green is for survived. So most of the people who embarked from port S died in this incident. Now this suggests another question. We may want to explore the class of the passenger and their port of embarkation. In this case, instead of hue equal to survived, we need to pass in hue equal to P class. Let's copy this code here and paste it in the next cell and pass in hue equal to P class. And if we run this cell, here we have P class blue for 1, green for 2, and reddish for 3. Now we see that Southampton was actually the busiest port for each class. Furthermore, we can see how many passengers traveled with siblings or spouses, and parents or children. We can plot a histogram to know how the age was distributed among the travelers. I encourage you to ask questions to yourself and try to apply your exploratory data analysis skills to learn more about the data. Use different type of plots along with your skills in interactive plotting as well. Recall the skills you acquired in the visualization section. Always remember practice is a key, and more you know about the data, better you will perform at the end. Let's get few more plots and then move on to the next step in which we will be getting our data ready for machine learning model. Let's plot the parent-children column and see how many survived. So SNS dot count plot pass in x equal to parch. Our data is train, and let's pass in hue survived, and let's run this cell. Clearly we see that bigger the group was, less chances for survival it has, whereas a single person has better chances for survival. Let's stop our exploratory data analysis at this point. Once again, I encourage you to ask questions to yourself and get yourself familiar with data as much as possible. I'm going to split this lecture here, and in the next lecture, we will continue and get our data ready for machine learning model. We will do data cleaning and convert the categorical features to dummy variables using pandas. See you in the next lecture, which is going to be the part 2 of logistic regression. Good luck.